This video is going to be about nuclear fusion on the main sequence. You might want to review what atomic mass and atomic number are before beginning this video. The fusion of hydrogen and helium takes place for the majority of a star's lifetime, and this is why most of the stars in the universe are considered main sequence stars, because they're still fusing hydrogen to helium. There's two ways to fuse hydrogen to helium. Smaller stars, similar to the mass of our sun, use a proton-proton chain. The first step of a proton-proton chain reaction starts with a proton and combines it to another proton. This creates hydrogen 2, otherwise known as deuterium, because one of the protons added to the nucleus decays to release a positron and a neutrino. The second step starts with a proton, which is combined with the deuterium made in the first step, which then produces helium-3 and releases a gamma particle. For the third step, the helium-3 is combined with the helium-3 from a separate reaction to produce helium-4, which is more stable than helium-3, as well as a proton and a second proton. The CNO process is used by larger stars with a hotter core temperature. Stars need a core temperature of 2 × 10⁷ Kelvin in order to fuse hydrogen to make helium through the CNO process. This is also done by main sequence stars. The first step of the CNO process takes a carbon nucleus and combines it with a proton. This creates the element nitrogen-13 and a gamma particle. Nitrogen-13 is unstable and it decays to carbon-13 in the next step, which releases a positron and a gamma particle. And a neutrino. In the third step, the carbon-13 combines with another proton to produce nitrogen-14 and a gamma particle. In the fourth step, the nitrogen-14 combines with another proton to produce oxygen-15 and another gamma particle. Oxygen-15 is unstable and decays to nitrogen-15, which releases a positron and a neutrino. The last step of the CNO process, the nitrogen-15 is combined with another proton to produce 2 nuclei, a carbon-12 as well as a helium-4. Notice that we've regenerated the carbon-12 that we started with, and we've produced helium. All right, that's the end. Thank you.